Okay, section 8-6, we're talking about probability and area, and this is the last section from Unit 8, so after this section we'll be done with the unit. Now, let's talk about probability. What is it? Okay, probability can be expressed as a fraction. One way it can be expressed is as a fraction, and that fraction is favorable over total, right? Meaning what you want over the total amount of things that are happening. So like, for example, just real quickly, the probability of flipping a coin and getting tails, well, what do you want? Favorable is what you want. You want tails. How many tails on the coin? 1. And then how many total outcomes? 2. So 1/2 would be the probability. So that's an example of how you would get probability. Favorable, how many outcomes of what you want, divided by total, how many total outcomes are there. That fraction is the probability. Okay, so now what we're going to do is answer questions like this. Find the probability that a point chosen at random lies in the shaded region. All right. So if we pick a point on this figure at random, okay, what are the probabilities that it lies in one of the shaded regions? All right. Now, here's how you've got to think about this. In problems like this, the shaded region, the amount of your shaded region is the favorable amount, and then of course the total area of the region is the total amount. Now when you've got squares like this, it's easy because all you have to do is count the squares. How many gray squares? There's 6. How many total squares? 3 by 5, there's 15. Alright? And so probability can be expressed as a fraction. You can either reduce that fraction, or it can also be expressed as a decimal. So if you divided this out in your calculator, you would get 0.4. Alright, and then for the purposes of this particular lesson, the probability is going to be expressed as a decimal. Alright, so you'll have to take the fraction and divide it out and put it as a decimal. Alright, so the next one. Okay, a little bit different. Again, a point's chosen at random. What is the probability that that point is going to be in the shaded region? Alright, so here's what we're going to have to do. We're going to have to find the area of the shaded region and put that over the area of the entire figure, right? Because we don't have just squares to count this time, so we're going to have to do it by area. The area of the shaded part divided by the area of the whole thing. Favorable over total. All right? So we already had a lesson where we were able to find area of the shaded region like this a couple of lessons ago. Now we're just going to take those areas and express it as a fraction or a probability. All right? So the first thing, remember, your top number is favorable. So the top number's got to be the shaded region. So the question is, how do I find the shaded region? Well, to find the shaded region, remember from 8.3, I believe, where we had to find the area of the shaded region by finding the area of the whole thing and subtracting off the empty space. Same type of deal here, because we need the area of the shaded region. Let's do that first. What's the strategy? Find the area of the whole thing, which is the area of the square, and subtract off the empty space, which is the circle. All right, so let's find the area of the square. Length times width, 20 times 20. So the area of the square is 400. Now let's find the area of the circle. Area of the circle is pi r squared. Area equals to pi times, let's see what my radius is going to be. Well, if all the way across is 20, my radius is 10. So the area of the circle is 100 pi. Alright, so how do I find the area of the shaded region? The whole thing, 400, minus the empty space, 100 pi. Alright. Now that's the area of the shaded region. We're not done yet because it asked me for the probability. All right? So that's the favorable amount. The area of the shaded region is the top number in my probability fraction. Okay? So I'm going to go ahead and make a fraction out of that. Now here's the question. What's the bottom number going to be? The bottom number is the total area of the figure. What would the total area of this figure be? The full area of the whole thing. Well, we already calculated it when we did the area of the square. So that number is going to go on the bottom. So again, the area of the shaded region on top, what I want, favorable amount, over the area of the total figure, which you will have already calculated to get the area of the shaded region. That number goes on the bottom. Now, the only thing that's left to do here is to divide it out in the calculator, and we'll come up with the right decimal answer. So again, I always suggest that you download Desmos calculator free in the App Store. It's got all the functions you would need in order to do whatever problems you need here. So like on this one, I'll go ahead and put divide. It makes a fraction automatically. Put 400 minus 100 pi. Go down to the bottom of the fraction, put 400, and then so there you go. You got it. I would round these to 2 decimal places. 0.21 is the right answer. 0.21. So you got a 21% chance of landing in the shaded region. All right, that's what it means. Okay. All right, what else we got? Let's try one like this. Okay, so again, the same question applies here. We want to know what is the probability of a point chosen at random landing in the shaded region. Okay, so again, the strategy is going to be the same. We want to find the area of the shaded region, right? The area of the shaded region. And then that's the top number of the fraction. And the bottom number of the fraction is going to be the area of the whole figure. All right, so how are we going to find the area of the shaded region? Now you could find the area of the whole thing and subtract off these 4 triangles. However, I would say that that's the long way of doing this one, right? Because this figure right here is a rhombus. All sides are the same length. And since we can get the diagonals, why don't we just go ahead and use the formula for area of a rhombus? 1/2 diagonal 1 times diagonal 2. 1/2 times, so diagonal 1 is going to be 14 plus 14, 28, and diagonal 2 is going to be 10 plus 10, which is 20. So that now multiplies out to make 280. So 280 is the area of the shaded region, right? So it's going to be the top part of my fraction, because shaded region is what I want, all right? Now the bottom number of the fraction is going to be the whole thing. Now by the way, the other method that I told you is that you could find the area of the whole thing and subtract off each one of these 4 triangles, and you would still get the same number here. But like I say, that's the longer way of doing it, but would still work. All right, now, so the bottom number is going to be the area of the whole figure. Well, what is the whole figure? The whole figure is a rectangle. So that's length times width. So what's the length of the rectangle? 14 plus 14, 28. Same as the diagonals. What's the width? 20. And so that'll multiply together to get 560. So 560 is on the bottom. And if you take a calculator and divide that out, you would see that that was equal to 0.5. So exactly a 50-50 shot at landing in the shaded region. 50% chance, half and half. Okay. One more we need to practice here. Let's take a look at it. Okay, so on one like this, the same procedure is going to apply. We got to find the area of the shaded region, and that's the top of the fraction. Then the area of the whole thing, and that's the bottom of the fraction. So the area of the shaded region, let's talk about how we're going to find it. We'll have to find the area of the whole thing and subtract off the empty space, right? So the area of the whole thing's a rectangle. Length times width. And so that's 10 times 20. And 200 is the length of the whole thing, or the area of the whole thing. Now I need to subtract off the area of the missing spaces, which is in the shape of a circle. Pi squared. Pi times my radius there is going to be half of 10, which is 5, so be careful with that. And so that's 25 pi. All right. Now remember, I'm trying to find the area of the shaded region, so I need to find the area of the whole thing minus the empty space. Well, the whole thing is 200. Now the empty space would be taking out both of these circles. Remember, here I just found the area of one of them. So if one of them is 25 pi, both of them together would be 50 pi, double that amount. So there's the area of the shaded region. Remember, We're trying to find probability, so that's the top number in the probability fraction. And then, of course, the bottom number in the probability fraction is the area of the whole thing, which we've already found to be 200. Then once again, now here I'm ready for the calculator to finish it off. So I'm just going to go up here and change that 4 to a 2. I'm going to change that 100 to a 50. And change that 4 to a 2. And you got it. 0.21 is the correct answer there. All right. So there we go. We're all set.